So when it comes to smart contract testing, automated testing is really where it's at. The consistency and speed you get from automation just can't be beat with manual methods.
I agree that automation provides a lot of benefits, but there are still some nuances that require human insight.
Absolutely. Human oversight is crucial, especially for complex logic errors or edge cases. But the bulk of repetitive checks should definitely be automated. It's like trying to find a needle in a haystack. Manual checks might miss something critical because of sheer volume.
True, but sometimes the test scripts themselves need meticulous tweaking to catch all potential issues.
That's why maintaining robust test suites is key. They evolve as your codebase evolves. Plus, integration tests help ensure that everything works well together, not just in isolation.
Yeah, but writing comprehensive integration tests can be quite challenging and time-consuming.
It certainly takes effort up front, but think about how much time it saves down the line by catching bugs early. Also, continuous integration pipelines make this process smoother. Every commit triggers a series of automated tests, which helps keep the project stable.
Continuous integration does streamline things significantly, no doubt.
And don't forget property-based testing. It generates a bunch of random inputs based on defined properties to check for correctness. This approach can uncover unexpected behaviors that traditional unit tests might miss.
Property-based testing sounds intriguing. I haven't had much exposure to it yet.
You should look into it. It's particularly powerful for smart contracts where security is paramount. Plus, tools like QuickCheck or Hypothesis can automate this type of testing efficiently.
Those tools sound promising for enhancing our current testing strategy. Yeah.
Definitely worth exploring. Automated testing isn't just about saving time. It's also about ensuring reliability and security in these high-stakes environments. Manual checks have their place, but they shouldn't dominate the process unless absolutely necessary. Speaking of robust test suites, let's talk about integration testing strategies for smart contracts. It's crucial to ensure that different components interact correctly and securely.
Absolutely, especially since the interactions can have significant financial implications.
Exactly. One effective approach is to use mock objects for external dependencies during testing. This way, you can isolate parts of your contract and focus on specific interactions without worrying about the entire system failing due to an external issue.
Using mocks makes sense, especially when dealing with complex dependencies.
Right. Another strategy is to employ a staging environment that closely mirrors the production environment. This allows you to run thorough tests in a controlled setting before deploying to live systems.
A staging environment seems like it would help catch issues before they become critical.
Definitely. Additionally, consider using stateful testing techniques where you simulate various states of the blockchain and check how your smart contract behaves under those conditions. This helps identify potential vulnerabilities or unexpected behavior in real-world scenarios.
Stateful testing sounds very useful for ensuring the contract handles different states properly.
It's essential, particularly for contracts that manage large sums of money or involve multiple parties. You also want to incorporate fuzzing techniques to generate random inputs and stress test the contract boundaries. Fuzzing can reveal edge cases that aren't immediately obvious.
Fuzzing could indeed uncover hidden flaws that regular testing might miss.
Agreed. Combining these approaches, mocks, staging environments, stateful testing, and fuzzing, provides a comprehensive coverage that significantly reduces the risk of post-deployment failures. While we're on the topic of testing strategies, let's talk about unit testing methodologies specific to blockchain environments. Unit tests are foundational and help ensure each piece of your smart contract functions correctly.
That makes sense. Each function needs to work independently before integrating them.
Exactly. One important aspect is isolating the blockchain-specific functionality. You can use frameworks like Truffle or Hardhat that provide mocking capabilities for Ethereum networks, allowing you to test individual functions without needing a full node running.
Mocking the network sounds like it would simplify the testing process significantly. Chilean.
It does. These frameworks also offer features like snapshotting, where you can save the state of the blockchain at certain points and revert back to them after running tests. This ensures that each test starts with a clean slate and doesn't interfere with others.
Snapshotting seems like a great way to maintain consistency across tests.
Definitely. Another methodology is using assertion libraries specifically designed for blockchain contracts. For instance, Chai Solidity allows you to write clear and expressive assertions about the state changes caused by your contract functions.
Assertion libraries tailored for blockchain seem very useful.
They are. They help you verify not just outputs, but also intermediate states and gas consumption, which are critical in blockchain applications due to cost considerations. Testing for gas efficiency is another key point. You want to ensure your contract operations are as efficient as possible.
Gas efficiency is definitely something to keep an eye on given its impact on transaction costs.
Absolutely. Tools like Ganache allow you to run local blockchains with configurable settings, so you can test different scenarios and measure gas usage effectively. Combining these tools and methodologies gives you a robust framework for ensuring your smart contracts behave as expected in every scenario. Moving on to another critical aspect, let's discuss security-focused testing approaches for smart contracts. Given the high stakes involved, ensuring the security of your code is paramount.
Security is definitely a top priority, especially with the potential for financial losses.
Absolutely. One effective approach is formal verification. It involves mathematically proving that your smart contract meets certain security properties. Tools like Certora or Y3 can help automate parts of this process.
Formal verification sounds rigorous but complex.
It can be, but it's worth it for mission-critical contracts. Another method is using static analysis tools specifically designed for blockchain code. These tools can detect common vulnerabilities like reentrancy attacks or overflow issues.
Static analysis seems like a good first step in identifying potential risks.
Indeed. You should also consider dynamic analysis, where you run your smart contract through various scenarios to see how it behaves under different conditions. This helps uncover runtime errors and unexpected interactions that might not be apparent from just looking at the code.
Dynamic analysis could reveal issues that static analysis might miss.
Precisely. Additionally, conducting regular security audits by independent third parties can provide an extra layer of assurance. They bring fresh eyes and specialized expertise to identify vulnerabilities that internal teams might overlook.
External audits are probably essential for larger projects.
Very much so. Implementing a bug bounty program can also be beneficial. By offering incentives to find and report vulnerabilities, you leverage the skills of a broader community to improve your contract's security.
Bug bounties can engage the community in finding and fixing vulnerabilities proactively.
Exactly. Combining these approaches, formal verification, static and dynamic analysis, security audits, and bug bounties, provides a multi-layered defense against potential threats.